Hello and welcome to Fundamentals of Cybersecurity, CSCI150N. This is Chapter 17, Web Components. I'm your instructor, Peter Keurig, and welcome. In this chapter, you will learn how to describe the functioning of SSL/TLS protocol suite, explain web applications, plugins, and associated security issues, describe secure file transfer options, explain directory usage for data retrieval, explain scripting and other internet functions that present security concerns, use cookies to maintain parameters between web pages, examine web-based application security issues. The outline for this lecture: current web components and concerns, web protocols, code-based vulnerabilities, and application-based weaknesses. The usefulness of the web is due not just to browsers, but also web components that enable services for end users through their browser interfaces. These components use a wide range of protocols and services to deliver the desired content. From a security perspective, they offer users an easy-to-use, secure method of conducting data transfers over the Internet. Many protocols have been developed to deliver this content, although for most users, the browser handles the details. From a system point of view, many security concerns have arisen, but they can be grouped into three main tasks: securing a server that delivers content to users over the web, securing the transport of information between users and servers over the web, and securing users' computers from attack over a web connection. When two people communicate, several things must happen for communications to be effective. They must use a language that both parties understand, and they must correctly use the language, that is, structure and syntax, to express their thoughts. So otherwise, it's like speaking one foreign language, let's say Latin, to somebody who speaks Portuguese, and they might understand some pieces here and there because of similarities between the languages. But if the context and the syntax is not properly used, then they're not going to understand what you're saying. The same requirements are present with respect to computer communications. They are addressed through protocols, agreed upon sets of rules that allow different vendors to produce hardware and software that can interoperate with hardware and software developed by other vendors. Because of the worldwide nature of the Internet, protocols are very important and form the basis by which all the separate parts can work together. The specific instantiation of protocols is done through hardware and software components. Web encryption uses two protocols: SSL, or Secure Socket Layer, and TLS, Transport Layer Security. SSL is a general-purpose protocol developed by Netscape for managing the encryption of information being transmitted over the Internet. TLS began as an equivalency to SSL version 3.0, so today SSL and TLS are essentially the same, although not interchangeable. Recent attacks have left SSL vulnerable, and the consensus is that SSL is dead and TLS is the path forward, although everyone calls it SSL. SSL-TLS uses a wide range of cryptographic protocols, and SSL-TLS is designed to be protocol agnostic. Although designed to run on top of TCP/IP, it can operate on top of other lower-level protocols, such as X25. HTTP is the workhorse of the web. Without it, the web wouldn't exist today, as we know it. HTTP is used for the transfer of hyperlinked data over the Internet, from web server to web browser. Although it was initially created just for HTML pages, today, many protocols deliver content over this connection protocol. HTTP traffic takes place over TCP port 80 by default, and this port is typically left open on firewalls because of the extensive use of HTTP. Likewise, since the inception of SSL and TLS, HTTPS, or Secured HTTP, has been the backbone of encrypted and secure web communication. It uses port 443. When websites were first deployed, providing HTTPS was a resource cost issue because it took processor cycles to encrypt all the connections. Today, with a variety of encryption technologies available, managing the resources of HTTPS connections is much easier, and a case has been made by many in security that all web connections should be HTTPS. If websites everywhere would turn off HTTP in favor of only HTTPS with TLS in light of the SSL vulnerabilities, this would not solve all the security problems. However, it would significantly reduce a lot of the security problems caused by attacks where people can intercept data as it's being transmitted unencrypted. HTTP Strict Transport Security, or HSTS, is a standard and a mechanism to enforce rules to prevent browsers from downgrading security when accessing a site. The policy states that when a web server provides an HTTP response header field named Strict Transport Security, then the user agent shall comply by not issuing insecure requests. HSTS was created in response to a series of attack profiles, the most critical being the SSL stripping man-in-the-middle or SSL stripping attack. Directory services, DAP and LDAP. A directory is a data storage mechanism similar to a database, but has several distinct differences designed to provide efficient data retrieval services compared to standard database mechanisms. The data is hierarchically described as a tree-like structure. To enable interoperability, the X500 standard was created as a standard for directory services. The primary method for accessing an X500 directory is through the Directory Access Protocol, or DAP, a heavyweight protocol that is difficult to implement completely, especially on PCs and more constrained platforms. The Lightweight Directory Access Protocol, or LDAP, which contains the most commonly used DAP functionality, can interface with X500 services, and most importantly, LDAP can be used over TCP with significantly less computing resources than a full X500 implementation. LDAP offers all the functionality most directories need and is easier and more economical to implement. Hence, LDAP has become the Internet standard for directory services. SSL TLS provides several important functions to LDAP services. It can establish the identity of a data source through the use of certificates, and it can also provide for the integrity and confidentiality of the data being presented from an LDAP source. The web provides the capability for file transfer using the FTP and SFTP protocols. File Transfer Protocol, FTP, is an application-level protocol that operates over a wide range of lower-level protocols. Most FTP implementations are designed to operate both ways, sending and receiving, and can enable remote file operations over a TCP/IP connection. Blind FTP, or anonymous FTP, allows unlimited public access to the files and is commonly used when you want to have unlimited distribution. On a server, access permissions can be established to allow only downloading or only uploading or both, depending on the system's function. Secure FTP, or SFTP, combines both secure shell and FTP to accomplish secure file transfers. SFTP operates as an application program that encodes both the commands and the data being passed, and requires SFTP to be on both the client and the server. When we're talking about web protocols and vulnerabilities, modern encryption technology can provide significant levels of privacy up to military-grade secrecy. The use of protocols such as TLS provides a convenient method for users to use cryptography without having to understand how it works. TLS cannot prevent security breaches. If the user is connected to an untrustworthy site, the mere fact that the connection is secure does not prevent the other side from running a scam. Using TLS and other encryption methods will not guarantee against your credit card information being lost by a company with which you do business. The TLS suite can protect data in transit, but not on either end in storage. In fact, most data breaches occur not because of data lost in transit, but because of data that was not properly stored and secured. Transfer of data is more secure thanks to protocols such as TLS. Next, the book looks at code-based vulnerabilities, specifically buffer overflows. One of the most common exploits used to hack into software is the buffer overflow. The buffer overflow vulnerability is a result of poor coding practices on the part of software programmers. When any program reads into a buffer, an area of memory, and does not validate the input for correct length, the potential for a buffer overflow exists. The buffer overflow vulnerability occurs when an application can accept more input than it has assigned storage space, and the input data overwrites other program areas. The exploit concept is simple. An attacker develops an executable program to perform some action on the target machine and appends this code to a legitimate response to a program on the target machine. When the target machine reads through the too long response, buffer overflow condition causes the original program to fail. The extra malicious code fragment is now in the machine's memory awaiting execution. If the attacker executes it correctly, the program will skip into the attacker's code, running it instead of crashing. Java is a program language designed to be platform independent and based on C. Java offered a low learning curve in a way of implementing programs across an enterprise independent of platform. Java operates through an interpreter called a Java virtual machine on each platform that interprets the code, and this Java virtual machine enables the program's functionality for the specific platform. Java was initially designed to be used in trusted environments, and then it moved to the internet for general use. In reality, most people don't interact with Java directly on the internet unless they're doing web-based applications. You'll find that most websites will use something similar like JavaScript or Virtual Basic Script or ActiveX. However, Java tends to be actually application-based. It tends to be centered more around developing a web application as opposed to just offering interactivity on a website. JavaScript is a scripting language developed to be operated within a browser instance. In other words, without a browser you cannot run a JavaScript. The primary purpose of JavaScript is to enable features such as validation of forms before they are submitted to the server. Although JavaScript was designed not to be able to access files or network resources directly, except through browser functions, it has not proven to be as secure as desired. JavaScript can also trick users into thinking they are communicating with one entity when in fact they are communicating with another. So JavaScript has been able to be used to access files on a system, and it's also been able to be used to create a sense of artificial intelligence or redirecting traffic from one intended site to an unintended site. ActiveX is the name given to a broader collection of application programming interfaces, or APIs, protocols, and programs developed by Microsoft to download and execute code automatically over an internet-based channel. The code is bundled into an ActiveX control with an OCX extension. To enable security and consumer confidence in downloaded programs such as ActiveX controls, Microsoft developed Authenticode, a system that uses digital signatures and allows Windows users to determine who produced a specific piece of code and whether or not the code has been altered. With Authenticode, you can determine if the person that developed the code is trustworthy, and you can decide for yourself if you want to run the code. Before there was JavaScript, before there was ActiveX, before there was Flash ActionScript, there was CGI. CGI, or Common Gateway Interface, was the original method for having a web server execute a program outside the web server process, yet on the same server. These scripted programs embraced the full functionality of a server, allowing access to database, Unix commands, other programs, and so on. I'll tell you, in my earlier days of web design, before JavaScript was available, back during the Netscape 1.0 days, I used CGI script in order to develop counters on my web pages, or to, at one point, I actually developed a chat room program that used a web interface and CGI to run the chat rooms behind the scenes by essentially taking input from the users and putting it into a chat file for the duration of the chat, much how AOL was able to do it later on. Now, CGI uses several different programming languages. Two of the most common were Perl and C. Now, Perl is a bit like Python, where it's an interpreted language, and it gets interpreted and compiled on the fly as it's running. On the other hand, C, you could write a complete program in C, then you would compile it, and you could tell the web page to execute the executable in a specific directory with a certain permission, allowing it to run on the system and produce results. Essentially, anything that you could do with any program written on your computer was allowed with the CGI Common Gateway Interface. CGI has been replaced in many websites through newer server-side scripting technologies such as Java, Active Server Pages, ASP, ASP.NET, and PHP. All these technologies operate in much the same fashion as CGI. They allow programs to be run outside the web server and to run data to the web server to be served to the end users via a web page. The term server-side script is actually a misnomer, as these are actually executable programs that are either interpreted or run in virtual machines. Cookies are small chunks of ASCII text passed within a HTTP stream to store data temporarily in a web browser instance. Cookies pass back and forth between web server and browser and act as a mechanism to maintain state in a stateless world. State is a term that describes the dependence on previous actions. So, for example, if you select that you want your page background to be blue, a cookie will be created saving that choice, and when you reload the page, it will read the cookie and set the background for the page to blue. A cookie is actually a series of name-value pairs that is stored in memory during a browser instance. The specified set of name-value pairs include the following. Expires, the field specifies when the cookie expires. Domain specifies the domain where the cookie is used. Path, this name-value pair further resolves the applicability of the cookie in a specific path within a domain. Secure, the presence of the word secure in a cookie indicates that it will be used only when connected in an SSL TLS session. Browser-based plugins. The addition of browser scripting and ActiveX components allow a browser to change how it handles data, tremendously increasing the functionality as a user interface. But all data types and all desired functionality cannot be offered through these programming technologies. Plugins are used to fill these gaps. Plugins are small application programs that increase a browser's ability to handle new data types and add new functionality. Sometimes these plugins are in the form of ActiveX components, Acrobat Reader, Flash, and more. So, for example, Flash is a browser plugin. It allows you to view Flash-enabled web pages and the content developed by them. So add-ons are pieces of code that are distributed to allow additional functionality to be added to an existing program. An example of these are browser helper objects, or BHOs, which provide a means of creating a plugin module that is loaded into the Internet Explorer and provides a means of adding capability to the browser. Other programs can have add-ons that abuse the permissions given to the master program. For example, if you've ever had Google Bar or Yahoo Bar added to your Internet Explorer, those are add-ons. Malicious versions of them have been released that monitor the advertisements on the page that you're viewing and your browsing habits, and can force advertising to you based upon your browsing habits. In addition, they can redirect you to malicious sites or sites that have paid for malicious activity, or sites that have paid to have you redirected to them when looking for certain topics. It could also be used to record keystrokes, usernames, and passwords on sites that are secure. Should you choose to install a browser helper object, be sure you know where the object was developed by whom, and what the object is specifically supposed to do. And if any abnormal activity happens on your system, immediately remove the browser helper object. As we briefly touched upon with the Authentic Code, they were looking for ways to ensure that software that was run off the web was safe to run on your system. So code signing was an attempt to bring the security of shrink-wrap software to software downloaded from the internet. Code signing works by adding a digital signature and a digital certificate to a program file to demonstrate file integrity and authenticity. Many of your companies these days now offer you download-only editions or a cheaper download edition of software that you could buy in the store. And you want to make sure that the software that you're installing on your system has been signed by the developer. The application software written to run on servers and serve up the content for users is also a target. Here we're talking about Apache or Tomcat or other web server type programs that are installed on a server to provide content. Web application security is a fairly hot topic in security, as it has become a prime target for professional crackers. Types of attacks include session hijacking, client-side attacks, cross-site scripting, header manipulations, and Web 2.0 and security. The book does a good job in covering each one of these types of attacks. I'm your instructor, Peter Keurig for Nashville Community College. Thank you for watching.